Hello guys and welcome back to our computer networks course. So in last lecture we learned about checksum, right? We saw how it is used, how it is calculated, right? How we use it to maintain our integrity, right? And we talked about our packages, right? We already know how our package is made, right? So from now on we would be going step by step and we would be looking into how our packages are sent and received, right? So we already talked about this, right? So this is a complete procedure where you establish a connection, then you send some data, right? There's your acknowledgements and your checks in between all of those things, and then you terminate your connection, right? So today we would be discussing how that certain connection is made, right? And then we'll follow along step by step, right? So let's go ahead. All right. So we already talked a little bit about this before, right? And we talked about what a three-way handshake is, right? So you guys already have some idea, right? So what happens is you have a sender and you have a receiver, right? So whenever your sender wants to send something, he says hi, right? And I said that hi was your sync package, right? So your sender would send a sync pack, right? Or a sync flag, right? A package with the sync flag activated, and the receiver would receive it and say, and he would know that, okay, this guy wants to communicate with me. So let's create a channel. Now he has two options, right? He can accept it or reject it, right? So if he wants to accept it, what he does is he says, okay, I will acknowledge it, right? I will acknowledge it, and I will also initiate the channel connection, right? So he will also send you a sync package, right? So I said hi and this guy nodded his head and said hi back, right? So I said hi, he nodded his head and said hi, right? Now I would have to acknowledge his hi, right? So I acknowledge his hi now. Okay. So that is your three-step process, right? I say hi, that guy acknowledges my hi and says hi back, and then I acknowledge his hi. And after this, we say that our connection has been established, right? So now our sender can start sending stuff. Okay. So that was your three-way handshake, right? So this is how our three-way handshake opens, right? So you send a sync package, you get an acknowledgement for it, then the receiver would send you a sync package and you would acknowledge it, right? Okay. So that was how your connection is established, right? Another thing that I want you guys to note is that we talked about sequence numbers, right? And we said that sequence number are simply the bytes that we have ordered, right? However, most packages would have a sequence number, right? The only guy that does not have a sequence number is your acknowledgement, right? So this guy does not have a sequence number. This guy would have a sequence number, and this guy would also have a sequence number, right? So this is just a single package, right? We talked about piggybacking, right? So these two are sent together. So again, acknowledgements are the only things that do not require a sequence number. Okay? So even if there is no data, right? Even if there is no data in your sync pack, you would require a sequence number. Even if there is no data inside your acknowledgement and sync package, you would require a sequence number. For acknowledgement, if there is data, right? If it is piggybacked, right? You would need a sequence number. If it is only acknowledgement, you do not need it, right? So the data requires a sequence number, but acknowledgement do not, right? Acknowledgement is the only thing that does not need a sequence number. All right. So let's see this example, right, that we have from our course. All right, so we started at sequence 8000, okay, and we sent a sync package, right? And then this guy acknowledges it and says, okay, I have received 8001, you can send me, sorry, I have received 8000, you can start sending me from 8001, right? So that is your acknowledgement, and it also sends a sync package, right? So it also sends a sync flag, okay, and it would also send you your receiver window size, right? So this is required, right? So this is what tells your sender this is the max amount of data you can send, right? So again, we talked about our tap pipe bucket, right? So this is your sender, this is your receiver, and this is your network, right? So we would talk about this more when we talk about congestion control, right? So let's not talk about that right now, but we know that a sender has a limit of what he can send, right? and the receiver has a limit of what he can receive, right? So the sender cannot send more than he can send, right? He cannot send more than he can send, and he cannot send more than the receiver can receive, right? So he cannot send more. Okay. He needs to make sure that it is at max this. Okay. He can send smaller stuff, but at max this, right? So matlab, what this stands for now is how much I want to receive at a given time. Okay. So we'll talk about Windows, and we'll talk about all of those things in detail a little later when we talk about how our data is transferred. But for now, let's focus on our connection, right? So now we sent a sync pack, right? That required a sequence number. Then we send another sync plus acknowledgement, right? That required a sequence number. Okay. But then we sent just an acknowledgement, right? So that did not require, right? So it is the same sequence that was before, right? Okay. It did not require a sequence number. All right. So moving on, that was how our connection is established, right? So this is connection opening. Okay. You're opening a connection. Now what about closing? So closing would happen in the same way, except your sync pack, right? Your sync flag is replaced by your fin flag, right? And fin is, right, we talked about this. Fin is what? Fin is simply end connection now. Okay, matlab fin is like, I am done. If you have something, you can keep going and I'm listening and we'll talk, but I don't have anything more to tell you. Okay, that is what your fin states. So again, same thing. Whenever one guy wants to close the connection, he would send a fin. Okay. He would send a fin. Now, if this guy also wants to close the connection, he's going to acknowledge that fin and send a fin himself. Okay. And now we would be acknowledging this fin, right? So again, three-way thing, right? And this is how your connection would be terminated. Now we have some other thing, right? So what if this guy wanted to end the connection, but this guy also did not want to end the connection, right? So this guy said, okay, I'm done. Whatever I wanted to tell you, I've already said those things. But this guy has some things that he wants to tell us, right? So what he would do is he would not send this fin here, right? So this was the first case, right? Let's talk about the second case in a separate diagram. Okay. So we have a sender, we have our receiver. Okay. Our sender said, let's send. Okay. So he sent a fin. Now receiver had some more information that he wanted to send. Okay. So he did not want to end it, but he has to acknowledge that fin, right? So what he does is he says, okay, I have acknowledged your fin. Okay, I have acknowledged your fin, but I do not want this to end now. There is some more things that I want to tell you. Okay. So this connection would be in a half open state, right? So you can call it a half open state or a half closed state. All right. Okay. So it's a half open or a half closed state, right? So it is closed from one side but open from the other side, right? So at this point now, the information transfer only happens in one direction, right? Kind of in one direction. Okay, so now what would happen is this guy would send whatever information he has to send, and then he would, at the end, when he's done, he would send a fin. Okay, and now we would acknowledge this. All right. So again, we have to send a fin from both sides and acknowledgement from both sides before the termination can actually happen, right? So right again, so who would require a sequence number and who would not? Your fin, of course, would require a sequence number. Acknowledgement plus fin requires a sequence number. Just an acknowledgement would not require a sequence number, right? Let's talk about this guy. So this fin requires a sequence number. This acknowledgement does not require a sequence number, right? Of course, it's just an acknowledgement, does not carry any data, does not carry any control message, right? So these are your control messages, right? We already talked about this, but your control messages tell what to do, right? So matlab, it could be push, it could be sync, it could be fin. There are many things, right? We already talked about those. Okay. So this guy would not require a sequence number. Then all of these data would require a sequence number. Okay. What about this fin? It would require a sequence number, right? And what about this ACK? It does not require a sequence number, right? This was fairly obvious. Acknowledgements are the only things that do not need a sequence number. Everything else would require a sequence number. All right. So now we know how we can make a connection. Now we know how we can end a connection, and now we can know Now we know how a connection can be in a half open state, right? So it is closed from one side but open from the other, right? So it can be since our TCP supports two-way communication, the half open could be in either state, right? It's not a sender receiver thing, right? It could be open here and close here, or it could be closed here but open here, right? It could be either way. So you can depending upon what the situation says. All right, so let's move on now and see how other things work. All right, so before we end this, let's talk about two more things, right? Let's go ahead and see first of all a situation which can occur but occurs very rarely, right? So let's see. So you have a sender, okay, and you have a receiver. Now what would happen if both of them wanted to connect to each other at almost the same time, right? So what I'm trying to say is this guy wanted to connect to him, so he sent a sync package, okay, sent a package with the sync flag, and this guy also wanted to connect, so he also sent a sync package. Now what would happen is you receive a sync, so you give a sync and acknowledge, right? So you give a sync and acknowledge, okay. Same for this side, you give a sync plus acknowledgement, okay. So what happened is, normally what happened was it was sync, then sync plus acknowledgement, and then another acknowledgement, okay. So notice that this last acknowledgement is not present here, right? This is the complete thing. So I said a sync and that guy gave me a sync and acknowledgement, right? So this acknowledgement already captures both the things, right? So this acknowledgement already captures both the things, okay. For matlab, this acknowledgement would do for this guy, right? And this acknowledgement do for this guy, right? So matlab, we don't have a need for the third acknowledgement, right? So let's see why that is, right? So let's see. I send a sync, okay, and then this guy sends me a sync plus acknowledgement, right? Acknowledging this, okay. And after this, this guy was supposed to send me a sync, right? But he has already sent me that sync. Let's see. So I send a sync, okay. Now this guy's reply was supposed to be sync plus acknowledgement, okay. This guy's reply was supposed to be sync plus acknowledgement, okay. Now my reply was supposed to be acknowledgement for his sync, right? This was supposedly the reply that I was supposed to give. But what happened was that this guy had also already sent me a sync back, okay, and I have already replied with an acknowledgement to that, okay. So I have already replied with an acknowledgement to that, right? So this acknowledgement is the same as this, right? We have already acknowledged his request to synchronize with us, right? We have already acknowledged that. So there is no need for this extra step, right? So this is how a simultaneous open happens, right? So both of them wanted to open a connection at almost the same time, and that is how they opened the connection at almost the same time, right? So the connection starts opening from both ends, right? But it opens almost at the same time from both ends, right? What normally happens is one guy would initiate the connection, right? Other one acknowledges it, right? And then your connection starts opening, right? For this guy, this is when the connection would start opening, and this guy starts opening here, right? But for our case, the connection starts opening at almost the same time on both ends. ठीक है? We don't have to wait for this, right? This is a very rare situation, right? So when a situation like this occurs, we simply don't need to have this extra acknowledgement, right? That is all it is about. ठीक है? All right. So that was our simultaneous open, right? Similarly, right, we also have a simultaneous close. ठीक है? So what would happen here? Your sender wanted to close the connection, right? And your receiver also wanted to close the connection at almost the same time. Okay. Now, when you receive a fin, you're supposed to give an acknowledgement. Okay. and that would be all right. So what normally happens is you would have a fin, and then there would be a fin and acknowledgement, okay, and then there would be an acknowledgement for the second fin, right? But again, just like how it was in our simultaneous open, we have already acknowledged this guy's request, so we don't need to acknowledge it again, right? Okay, so we won't have to acknowledge it once more. So that was your simultaneous close. Okay, that was the first thing, right? There was something that we discussed, but not exactly, right? And that was that this guy, right? We said, did I remove the diagram? I did, right? Okay, let's make it again. So we have a sender, we have a receiver, right? And we said this guy sent a sync pack. Okay, and now this guy had two options, right? First was to accept and the other was to reject, right? So we talked about acceptance, right? We said if you want to accept, send a sync plus acknowledgement back, right? But what if I don't want to accept? What if I want to reject? So if I want to reject, instead of sending a sync plus acknowledgement, what I would be sending is a reset packet, right? That means that I cannot maintain a connection with you right now. Please try again later, right? Well, this is basically, again, we talked about this before, right? There is some error and we must abort this connection, right? So this is, right, this guy says, let's make a connection, let's talk, and this guy just cuts the call, right? He says, abort, we cannot make this connection right now, we cannot be talking right now. Okay. So this was our reject case for when we are trying to make our connection. Okay. All right, so let's move on. So before moving on to how our data is transferred, let's talk about one severe issue with our connection protocols, right? So let's see. So I have a sender and I have a receiver, right? And I said I would send a sync package, okay? And this guy would replies me with a sync plus acknowledgement, right? And then I send it an acknowledgement, right? And that is how a connection is maintained. Now, what do you think would happen if I flood this guy with sync packages, right? If I send 100, a million sync packages to this guy, right? He would be overwhelmed with the number of connections, right? And he would eventually start rejecting. Okay? He would eventually start rejecting, right? So, he gets a lot of sync packages, right? He's getting sync. He would accept some that he can, and then after a certain point of time, he would be at his capacity, right? He could not accept anymore, right? Before these are closed, he could not accept any more connection, right? So he would start rejecting them. Okay, he would start rejecting them, right? And this kind of thing can be exploited for malicious purposes, right? So this is what basically your denial of service is, right? This is what basically your denial of service does. Okay? Denial of service. It is also known as sync flooding. Okay? So basically what you're doing is you have a sender, you have a receiver, okay? And you make it so that the receiver thinks that your sync is coming from different people, right? Because if it is coming from the same person, it would simply be treated as a duplicate, right? And it would not be treated as a separate connection, right? So you make it so that it looks like it's coming from different hosts, right? So this guy accepts, and at some point it reaches its limit and says I cannot accept anymore, and that simply means that if there is some other sender that tries to connect to it, it would be rejecting that as well, right? If there is another sender that tries to connect to it, it would be rejecting that as well, right? It would be rejecting all those things. Okay, so that was your denial of service or sync flooding, right? We flooded with so many connections that it becomes incapable of connecting with anybody else. Okay, so that was your denial of service. Now maybe you guys have not heard of denial of service as like that, but you must have heard of DDoS attacks, right? So DDoS is simply denial of service, but it is on a distributed scale, right? So instead of using just one host, like I said, we would be using many hosts, right? So for example, the solution to this problem would be that I figure out where this is coming from and I block that guy's IP, right? So any connection that is from this guy, I would be rejecting this, right? Okay. Well, I somehow make sure that I can identify this and I start rejecting everything from it, right? So now there is your DDoS, right? So in that, I do not have one sender. Okay, I would have 100 senders doing the same thing, right? 1,000 sender doing the same thing. So it becomes much more difficult to identify where it is coming from. Okay. So this is simply distributed denial of service. Distributed denial of service. Okay. So the exact same thing done over scale, done over different many hosts. Okay. Instead of one sender, you have many senders doing the same thing, and that is your denial of service. All right. So let's finally move on to our data transfers.